the very first thing that crosses your mind, or rather that catches your eye, is this black base. It is made of plastic. Yep. And this is used in conjunction with this particular pole here. You will see there are screw threads here. You see there are screw threads here, and this goes there. Okay, and it will look something like this. No, I did not screw it in fully. It's okay, you should screw it in fully. Okay, and it's a nice touch that the top is actually rubberized, okay, to prevent injuries and whatever. Okay, and this one is used in conjunction with these ring magnets. Okay, now the ring magnets itself are clearly labeled, are clearly colored red and blue. Okay, whether or not they are actually north and south is something that we can test it out, but it really doesn't matter. Okay, because the whole purpose in using this ring magnet, as can be seen in the picture, on the cover of the box, that okay, like poles will repel and unlike poles will attract. Okay, so it will look something like this. Yep. So one of the first characteristics of magnets that we learn is that like poles will repel and unlike poles will attract, and you can actually do a magic show kind of a thing if our P3 kids. Our P3 kids are still very much interested in science. Everything is new to them, and this will be a very fun activity that they can handle on their own to learn more. Okay, and you can play along by, you know, pretending to be a magician or that kind of a thing. Okay, so that is one of the first objects that we are taking a look at. Okay, now subsequently you will see there are paper clips here. Okay, this kit is meant to be standalone, so you don't really need to go out and source out for paper clips and so on. Those of you who have been teaching magnets for quite a number of years, teaching science for quite a number of years, you will know that this is linked to the strength at different parts of a magnet, specifically to see whether or not which part of the magnet is stronger. Is it the poles or is it the middle of the magnet? And normally we use this with bar magnets that we can find in the bottom layer over here. Okay, so those are paper clips. Okay, and since these magnets are all these magnets here are pretty much new. Okay, they are pretty strong. Okay, and you may want to tell your kids to be a bit more careful in handling them. Okay, you also have a compass, yep, which will tell you the direction, and to see this will link towards the activity where a freely moving magnet will rest in a north-south direction. What you can do is to actually take this by itself, you know, put it somewhere in the class, perhaps as a teacher demonstration. Okay, put it somewhere away from magnetic interferences. Yep. Okay, and let it rest. You will see that the red will point north, the white needle will point south, and that's pretty much it. Leaving it there. Okay, if I were to jump a little bit and use this is a piece of foam. This is a piece of foam that you can put a magnet over here. The magnet is doesn't need to be secured. You can actually float it on a piece of plastic Tupperware or plastic container with water. Let it rest, and you'll find that the magnet will rest in the north-south direction. One thing to take note is this should not be done too close to the compasses. If not, the compass needle will be attracted to the magnet. Okay, so yes, you can do this as a team activity, as a group activity, but for those of you who want to demonstrate it in class, fine, you may carry on. Okay, I'm gonna stop this video for just a while, okay, just to break up the size of the video proper, and then in the next video I will actually show you the other parts that I see.